Good morning, everybody. Welcome to Natural Science Grade 8. I'm Arisa Hafaji, and I will be helping you understand what resistors and resistance are. Okay, I won't be able to take questions today, which won't be a problem, but I will be able to tomorrow. So by the end of this lesson, you will know more about resistors and resistance in a light bulb. So I'm doing this section, but not a lot of electricity. I'm going to end with electricity at the end of this week, only because I want you to understand how the flow of electrons work to give you electricity. Because we did start with particles of matter, and I want you to be able to relate it to something concrete so you're able to understand what particles of matter are. Okay, so revision from yesterday, not yesterday, sorry, from last week, a quick recap. A circuit is a system of transferring electrical energy. For a circuit to function, there must be a complete pathway for the electrons to flow. So that means that the circuit cannot be broken. It must have a source of energy. So the source of energy is basically a cell or a combination of cells, and it must have a load. Now, a load would be a light bulb or any other form of resistor that gives you light. We use a symbol to represent components of an electric circuit so that everybody can interpret the diagram. So basically, when we drew an electric circuit, like how I showed you last week, there were symbols. So these symbols are universal. That means anybody, anywhere in the world can know what you're talking about if you had to draw a circuit diagram, because it's universal symbol across the world. Okay, so they can interpret what the diagram means, even if they speak a different language. So what you need to know is that opposite charges attract each other, and negative attracts positive, and a positive would attract a negative. So when we say opposite charges attract each other, this means that negative attracts a positive and a positive attracts a negative. So this is basically just this part. Negative attracts a positive is the opposite of positive attracts a negative. So a discharge of electrons from a charged object can cause sparks or shocks of static electricity. So that means where one object gains more electrons, then you would get static electricity. And this occurs mainly when the air is dry. So you'd get a shock when there's lots of electrons. So this causes static electricity. This is caused by static electricity. And just to recap, it is a transfer. Discharge means the transfer of electrons from a charged object onto another object. Okay. So now by the end of this lesson, what I want you to know more about is, sorry, something, what I want you to know more about is this resistors. And when you're going through this, I actually don't want you to get excited and say I'm going a bit too fast, because I will explain everything to you slowly. So resistors are made of materials that resist or oppose the flow of electrons in a circuit. So we say resistors. Resistors are made up of materials. So the main thing here is that it resists or it opposes. Opposes means to resist the flow of electrical current in a circuit. Okay, so resistors in a circuit have an influence on the amount of electrical flow in that circuit. So basically what this means is that the resistor influences how much of current is flowing in the circuit. Okay, so it controls the amount of electrical current in the circuit. So you get some resistors, that's including bulb filaments, heating wires, elements in kettles, heaters, geysers, stoves. So they can provide useful amounts of output energy. So by controlling the flow of electric current in a circuit, you actually control how much heat is given off, and this prevents protects you. It prevents you from dangerous happenings. So a light bulb, such as a torch or a bulb, contains resistors called a filament. So the filament heats up the white hot when it is connected to a circuit. So I'll explain more about that when I show you a picture of a light bulb, and then I'll explain what the filament is. And the resistance wire is connected to two contact points. So if you looked at a bulb, I'm sure most of you have, at the end, at the bottom of it, there's two contact points. And then it has one end of a screwing part, that's the casing, and the other end of a solder knob at the bottom. And these two contacts are separated by an insulator. And I'll explain what an insulator is. Okay, so you're going to ask yourself the question. She's talking about resistors, but how can I define it if they ask me in class? So let's look at this. In order to work out what they are, let's first remind ourselves about conductors and insulators. So when we understand more about conductors and insulators, then you'll understand more about resistors. So we are specifically looking at electricity, so we can talk about more electrical conductors and insulators. So an electrical conductor is a substance that allows electrical charge to move through it. So we have an electrical conductor. So an electrical conductor is a substance, and it allows an electrical charge to move through it. Okay, so an electrical conductor is a substance which allows an electrical charge to move through it. And an insulator is a substance which does not allow an electrical charge to move through it. So we basically say a conductor is an electrical conductor promotes electricity. It's a good conductor of electricity. And we say an insulator, it does not conduct electricity. It basically protects you from the electric current that is passing through. So if you looked at a wire, okay, like even of the charger of your phone or the charger of your iPad or your laptop, it's covered with a rubber substance, a rubber wire. So this wire is protecting you when you hold it from the current that is passing through inside it, because the current that's passing inside it is basically heated, and it will be hot, and you won't get burnt or you won't get electrocuted and that's the function of an insulator, to protect you from an electrical shock. So think back about the model of metal wire and how the electrons were able to move through the wire. So remember last week I showed you that the electrons move in one direction, and so now basically also, so in a wire the electrons are moving from the switch to and the power source through the switch to one direction to where you want your appliance to work. So it's moving all in one direction. And the wire is a conductor of electricity. So we say that this wire, metal wire inside, is a conductor of electricity. So you can think of some materials that do not conduct electricity, and you can write them down. And while you're doing that, I'll wait for 20 seconds for you to write it down, and then I'll give you the materials that do not conduct electricity very well. Okay, so the materials that do not conduct electricity are basically rubber, oil, glass, wood, and diamond. So it's rubber, oil, glass, wood, and diamonds. Okay, so do you think that most conducting wires are surrounded with plastic? Let's see. Perhaps the most important reason why electrical wires are covered in plastic is to protect you from an electrical shock. So in the test, they can ask you this question. Why do you think that conducting wires are surrounded with plastic? So your answer would be it's to protect you from electrical shock. And then you can say electricity is, and then if they ask you, explain your answer. So you're going to say electricity is a dangerous form of energy and it can kill you. And covering electrical wires in a plastic guarantees that the electrons flow through the wires and it will not flow through your body when the wire is touched by you. So when they ask you why are wires covered with plastic, you're going to say it's going to protect you from electrical shock. And then you're going to say, and if they ask you, maybe if it's a 2 or 3 mark question. So 1 mark, you would say it would protect you from an electrical shock. And then for 2 or 3 marks, they say, explain your answer. So your answer would be, electricity is a dangerous form of energy and it can kill you. So covering electrical wires in a plastic guarantees that the electrons flow through the wires and it will not flow through your body when you touch the wire. So you're basically being protected, okay, when you touch the wire. So we have basically to show you here a conductor. It's any material that allows electrical current to pass through it. So in the test, if they can ask you, what is the difference between a conductor and an insulator? So you will say, a conductor is a material that allows an electrical current to pass through it, while an insulator is any material that does not allow electrical current to pass through it. Okay, so you'd get 1 mark for what is the conductor and 1 mark for what is a insulator. So I'll repeat it. A conductor is any material that allows electrical current to pass through it, and an insulator is any material that does not allow the electrical current to pass through it. Okay, so an insulator is something like a protective glove that protects you. It's a cloth, it's wood, like in the electric poles, you can see here at the bottom, it's held with wood at the bottom, rubber, and then if you can see the end here is the wire sticking out, and this red part here on this plug is the plastic that protects you. So when we're going onto the left-hand side where the conductor is, examples of a conductor are copper, aluminium, steel, and any metal is a good conductor of electricity. And if you look here, you'll see in the wire here. So this black part is the insulator, and this copper part here is the conductor, where the electrons flow through it to give you electricity. Okay, so now you can ask yourself the question, so are resistors basically insulators or are they conductors? Does it conduct electricity or does it stop electricity? So the answer would be is that it's a bit of both. They allow electrons to flow through them, but it doesn't make it easy. It actually resists the movements of the electrons. So the resistance basically influence the electric current flow. Okay, and Nati, I will take your question tomorrow, not today, because we're having a little technical difficulty. So don't worry, you can ask it me tomorrow. So resistance, we say resistors therefore influence the flow of the electric current. And there's 2 types of resistors. You get one normal resistance and then you get a variable resistor. A variable resistor we'll discuss later on. Okay, but just so that you know for information's sake, a variable resistor basically controls the flow of energy through the circuit. So you can dictate how much of heat or how much of energy you want to transfer through a circuit. Okay, so we say, but why would you want the resistors to resist the movement of electrons? Like, resistors are extremely useful. So think about a kettle. So now if you look at the picture here on your right hand side, and if you look inside here, you'll see this large metal coil. So this metal coil is a heating element, and if you plug it in the switch and you switch on the kettle, the element heats up the water. And the element is a large resistor. So in it, it has a resistor that controls the amount of heat that you're going to give off to make the water boil. So remember, water boils at 100 degrees Celsius. So this resistor controls that temperature to allow the water to boil at 100 degrees Celsius. So when the electrons move through the resistors, they expend a lot of energy in overcoming the resistors. And they expand, and this energy is transferred to the surrounding in the form of heat. So by this transfer of energy, it basically gives off heat. Now the water is getting very hot, so this is heat. And this heat is useful as it heats up the water. Okay, so we need heat to heat up the water, and it is done through the flow of electrons in a circuit. So the first light bulb was made in the 1800s by a man called Humphrey Davy, and he invented an electric battery. And when he connected the wires to it and a piece of carbon, the carbon glowed. And this carbon was a resistor that produced light. And through experimentation, just like how you're going to experiment and you're going to become young inventors, um, we found knowledge. We expanded our knowledge and we made new things. So imagine in 1800s, this man here first produced light, and then later on, Thomas Edison experimented with thousands of different resistors. So as technology improved and increased, then more materials became available, so which allowed Thomas Edison to experiment with different resisting materials until he eventually found the right material that would make a bulb glow for over 1,500 hours. So that's 1,500 hours. So remember that being a young scientist allows you to have a creative mind and experimental mind. And when you explore, you would gain more knowledge and you learn things. And through experimentation is also through trial and error. So you try this, you see it doesn't work, then you try something else until you make it work. And it's actually fun. So let's take a closer look at the different parts of a light bulb to see how resistors work in a bulb. So I'm going to show you a picture of a light bulb, and then you can see how it works. Okay, so we have all these numbers here, and I'm going to introduce you to a new word, incandescent light bulb. So incandescent means to emit light as a result of it being heated. So basically we're emitting light, so we're giving off light because we are heating this light bulb. So it's through an electric circuit. When we heat it, the light glows. So you're going to listen to the information that I'm going to read to you, and you can look at the numbers and I'll point it to you, and then we can go through the questions that I have later, and then it will answer your questions that you may have. Okay, so a light bulb consists of an airtight enclosed glass case. So you look at number 1. So around this light bulb is a glass case. Okay, and at the base of the light bulb, there's 2 metal contacts. Remember I told you earlier on, I'm going to show it to you. So point number 7 is the one behind, and here's number 10. You have these metal contacts, and these connect to the ends of an electric circuit. So those metal contacts basically connect to your circuit, to the copper wire, and the metal contacts are attached to 2 stiff wires. So now we're going to go up the circuit, and we're going to look at number 3, which is this, and number 4, which is that. So these metal contacts here at the bottom, they are attached to this metal part that go up here. Okay, so the two dots at the bottom of your globe are actually going up in metal up here to reach this part here. Okay, so these wires are attached to a thin metal filament. And have a look at the light bulb at number 2 in the diagram. So this number 2 in this diagram here is a filament. So it's attached to this filament, and this filament has a high resistance. So it means that the light bulb will glow when they make contact with each other, and the higher the resistance means that it controls more energy to go through it, and it can make your light bulb glow much higher, brighter. So when the electrons move through the filament, they experience high resistance. Okay, so this means that when it's going through the filament up, it's experiencing high resistance, and there's a lot of transfer of energy in the filament to pass through it. So lots of energy is passing through this filament, and the energy is transferred to the surrounding in the form of heat and light. So in your test, they can basically give you the sentence, they can give you information, and then they're going to ask you to describe the energy transfer in the light bulb. Okay, and then you would say, electrical energy is transferred to heat and light. So the transfer of energy is basically you converting electrical energy to heat and to light. So you could say there's a conversion of electrical energy into heat and light energy. So the energy that is transferred to form heat and light is the transfer of electrical energy into heat energy. So the next question, what is useful energy output and what is wasted energy output in the light bulb? So let's see what we mean by useful energy and wasted energy. Okay. So light is a useful output and heat is the wasted output. So light means that the purpose of the light bulb is to give you light energy. So we want the light. And the wasted energy is the heat. So we don't really want the heat, but we want the light. So that's why we say useful energy and wasted energy. So even though it's giving off heat, light and heat, the purpose of the light bulb is to give off light. So that's what makes it useful. And it's also giving us heat. So we don't really need the heat. So that's why we say it is wasted energy. So it's a wasted output. So an output is also the result of an action. So when we say you get an input is what you're putting in, and the output is the result. So if we look at question 1 again, so the input is electrical energy, we're putting in electrical energy, and the output would be heat and light. So that's the result. That's what we are getting out of it. And then why do you think that the filament is coiled? So now in the kettle and also in the light bulb, you saw that the filament was coiled. So the answer is, this is to fit a longer length of Tungsten wire. Now the reason why they use Tungsten is because it's the metal that has the highest resistance for energy to pass through it. So it's one of the better conductors of electric current. So you have a longer length of Tungsten within a small space to increase the resistance and therefore make your light bulb brighter. So it is coiled because now imagine if you had to take wool and you had to take the wool and you had to wrap it around your finger. And that amount of wool that you are wrapping around your finger eventually looks very small. But if you had to open the wool, it would be a long length of wool. Okay, so that small long length, when you're wrapping it around your finger, actually looks smaller, even though it is long. So this is why we say that the filament is coiled, because you're increasing the resistance by making something long appear small for it to glow brighter. Okay, so now this is the filament here. Okay, so imagine if you had to expand it. Expand it means that if you had to put it in one long line. So if I had to open that coiled filament up, it's going to make a long line. Okay, so this whole wire here, let's just say that this is your wire. If you wrap it round, like round, 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 it makes that whole long wire fit into a small space. So you have greater amount of output, greater amount of light coming out. So the filament is mounted on a glass stem. So if you look at number 5, this is your glass stem. Okay, and there are small and these two small spout wires to hold the filament. So now you look at the glass stem, and it has these two small wires that is holding the filament attached to the glass stem. So now they ask your question, now why does it have glass? Okay, so now remember at the beginning I asked you what were good conductors of actually I asked you what were good insulators. So let's look at the answer. Okay, this is so that the electric current can pass through the electrical contact at number 10. So now glass is a good conductor of electricity. So that is why they're using glass. So this filament, this wires here attached to the filament on the light bulb goes through the glass, which is a good conductor of electricity. And it joins with these wires here, and they go right to the bottom here, right, and they touch the metal insulating cap, and that is how electricity is transferred through a bulb. Okay, so the inventor who made this did this through trial and error, through experimentation, which is what you can do later on as you get more experience and more knowledge, and experiment, because the only way to gain experience is to read and gain more knowledge. And when you have this knowledge, you can actually put it into use. So the amount of resistance in a substance offers in a circuit is actually measured in ohms. So we say that resistance is measured in ohms, and this is the symbol of it. But I'm not going to get into this in this lesson, because I just want to introduce you to it to show you how electrons flow, because it relates to matter of material, which is what our section is. Okay, if we want to use resistors to control the flow, electrical current flow, then we need to know the amount of resistance. So now if you look here at the picture, there's a whole lot of resistors, and you can see some are small and some are huge, and they all are varying lengths. Varying lengths mean that they all have different lengths. So can you see what's common in all of this? Can you see that the resistors color bands on the resistors, this isn't just to make it look appealing to the eye. So these color bands doesn't mean that it's just there to make it look pretty. So it's there for a purpose. And the purpose is that the color bands are actually a code that tells us the resistance of the resistor. So these color bands will tell an electrician what the code is and what the measurement of the ohm is. Okay, what the measurement is and how much resistance it offers, so whether to use it or not to use it. And we also get resistors where we can adjust the resistance themselves. So now that is what I was talking to you about, a variable resistor. So this is where you can adjust the amount of electrical current in it. So you've already seen a symbol for a resistor in a circuit diagram. Okay, so that was our previous lesson where I showed you the symbol of the resistor, but I will show it to you later again. So I'm going to give you homework, okay, and your homework would be to draw a circuit diagram in the space below with two bulbs, two cells, and one open switch and a resistor, okay, and I'm going to write it on the next page here, and there you have it. So I want you to copy this down. I'm going to give you 2 minutes. It will give you time to basically write down the question, draw the symbols of each um, component, and write the component next to it. And then I want you to draw a circuit diagram with two bulbs. That means two of these bulbs here. Then two cells. Okay, so it will be something like that. And an open switch. So we have the open switch. I'm just going to take this and move it top. We have our open switch here and a resistor. And this is the symbol for your resistor. Okay, so I'm going to time 2 minutes. You can take down the question, the components, and the circuit symbols, and you can draw a circuit diagram. And remember that you must use a ruler, because in your exam or in your test, if you do not use a ruler, they will deduct marks for untidiness. Okay, so make sure that you use a ruler. Okay, so 2 minutes starting from now. Okay, 1 more minute. I'll explain while some of you are writing. A wire is that straight line. The resistor is a straight line with upside down V's, like, and then straight line again. The light bulb is a straight line with a circle and X in the middle, and then a straight line. Then we have a cell, a straight line. The long line is a positive, then the short line is a negative, and then you have a straight line again. Then we have a battery, which is basically two cells. Don't worry too much about the battery, worry more about the cell. And then we have a switch. So it's a straight line, a big dot, then a line going up to show it's open. Then just below where the line going up, then a line going down, then a big dot here, and then a straight line again. So those are your symbols. So your homework is basically to draw two bulbs. So you're going to draw two of this, then two cells. So this would be one cell and then another cell. So it will look like that. An open switch. So here's your open switch. And then you're going to add a resistor. Okay. So to summarize what we did today is basically resistance is a measure of how much work can be done for a charge to flow through a circuit. Okay, so resistance is to measure how much of work is done for a charge to flow through a circuit, and it is measured in ohms. A resistor is an electrical component that limits or regulates the flow of electrical current in an electronic circuit. And resistance can also be used to provide a specific voltage. So we have a resistor. I'm just going to go through it again. is an electrical component that limits or regulates the flow of electrical current. Okay, and it provides a specific voltage. A resistor is an electrical component with a predetermined electrical resistance. Predetermined means that they specify the amount of resistance that it can control. Like for example, you get a resistor with 1 ohm, a resistor with 10 ohms. So you have to use a resistor to suit the current that is going to go through it. You can't use a high resistor or a low resistor. It has to match with the flow of current. Okay. If you use a too low resistor on a high current, then it's going to break the circuit and the flow energy, the current won't flow through the system. So resistance is a property of a conductor which determines the quantity of current that passes through it when a potential difference is applied across it. So basically what we're saying is resistor promotes the transfer of electrons, and potential difference is how much of current is going to flow through it. It controls the flow of current that is going through it. And then resistance allows electrons to move through them, and it does not make it easy. So this sentence here basically means what the one above said. And they are said to resist the movement of electrons, and resistors influences the electric current. Okay, I hope you understood everything that I said. If you want more information, you can visit the textbook, which is from Sue Vela has a textbook. It's a basic Department of Education book as well. It's the same. And then you can visit this YouTube site that tells you how a light bulb works. It shows you exactly how a white light bulb works. I'll give you a few seconds to take down the YouTube site. Okay, so our next lesson is going to be basically effects of an electrical current, and I'll be explaining heating and melting metal to you. And I hope you can contact me on my email if you have any questions, which is aajffea@gmail.com. And I will be doing a recap of today's lesson tomorrow. I had a lovely time explaining the information to you, and I hope you have a splendid, lovely day. Happy learning and enjoy your day. Goodbye, everybody.